two touching bars 1 and 2 are placed on an inclined plane forming an angle alpha with the horizontal as shown in the figure. The masses of the bars are equal to m1 and m2, and the coefficients of friction between the inclined plane and these bars are equal to K1 and K2 respectively, with K1 greater than K2. Now we have to find the force of interaction of the bars in the process of motion and the minimum value of the angle alpha at which the bars start sliding down. Now, in order to find the force of interaction between the bars during the process of motion, we have to look whether the blocks will remain in contact or not. The force of interaction will only be there if both the blocks remain in contact, and for them to remain in contact, the acceleration of block 1 must be less than the acceleration of this block 2. Now for this we have to look at the number of forces acting on these two blocks which are accelerating them. So for this, let's draw the free body diagram assuming that they are not in contact. Now this is block 1, this is block 1, and in this direction means along the incline, this force is mg sine of alpha. Clear? And it is the component of the weight that is acting down. Now the force of friction is in this direction. Let this force of friction is F1. Now this F1 is equal to K1 mg cos alpha, where this mg cos alpha is this component of the weight, and this mg cos alpha is the normal reaction for this block 1. Now suppose this block is accelerating in this direction along the inclined plane with an acceleration w1. So from here we can write this w1 as g sine alpha minus k1g cos alpha. Clear? I have used Newton's second law of motion. The sum of forces is equal to mass into acceleration. So from here we have calculated the acceleration of this block 1. Now similarly for block 2, this is block 2, the force acting on it in this direction is m2g sine alpha. In this direction it is m2g, and its component in this direction is m2g cos alpha, and the force of friction acting here will be F2. This is equal to K2 m2g cos of alpha, and this is, say, moving with an acceleration w2 along the incline. So from here we can write that this w2 is g sine alpha minus k2g cos alpha. Now this is our equation 1, say, and let this is equation 2. Now if you compare this equation 1 and equation 2, means the acceleration of both these blocks. Now this part is same in both these equations, and this factor is also same. So only thing which we have to compare here in our situation is this K1 and this K2. Now in the question it is given that K1 is greater than K2. Now this K1 is greater than K2. K1 greater than K2 means that this factor, this whole factor, is greater than this vector. So from here we can say that this W1 is less than W2 if they are allowed to move freely. Means this block 2 will hit this block 1 and both the blocks will come down the inclined plane with some common acceleration. Now it is clear that both these blocks are coming down with a common acceleration, so we can think of force of interaction between these bars or blocks. Now suppose the force of interaction between the blocks is, say, F. This is the force by block 2 on block 1. So from third law of motion we can say that the same force will be applied by 1 on 2. Clear? So taking this force F into picture, so we can draw this F here. So this is the interaction force from 2 on 1 and this is the interaction force from 1 on 2. Clear? So here we have to find this F. For this we have to use Newton's second law of motion again, and as we have written this equation 1 and 2, we can write that m1g sine alpha minus k1g cos alpha plus F, because this force is acting in this direction, means along mg sine alpha, so both these forces will get added, and this force F1 is acting opposite to both these forces. Clear? So the sum of forces will result in this equation, and this is equal to mass into acceleration. Clear? And this is the acceleration, means the common acceleration with which both the blocks are coming down. Both the blocks are coming down with this acceleration W. Clear? So this is the acceleration W with which both the blocks are coming down. Similarly, we can write equation for this block 2, and this is m2g sine alpha minus m2g cos alpha k2. So here we have to put m1 also, and minus of F. So if you look at this FBD, so it will be minus of F, and that is equal to m2 into W. Clear? Now suppose this is equation number 3 and let this is equation number 4. Now if we divide both these equations, so dividing equation 3 by equation 4, so we are dividing them to eliminate this W so that we can find out this force F, the force of interaction. So we can write m1g sine of alpha minus m1 k1 g cos of alpha plus F is equal to m1 W divided by m2g sine of alpha minus k2 m2g cos alpha minus F, and this is m2 W. So W gets cancelled, and if we cross multiply and solve this equation, we will get finally F equal to m1 m2 g cos alpha into k1 minus k2 and divided by m1 plus m2. Clear? So this will be the force of interaction under the condition that this k1 is k2, and if condition is reversed, that K2 is greater than K1, then both these blocks will move independently and the force of interaction will be 0. Clear? This is also evident from both these equations 1 and 2. Here, if K2 is greater than K1, so this factor will become more, and then this W2 is less than W1. This means the acceleration of this block 1 is more than the acceleration of block 2, and there will be no force of interaction. Clear? So we have answered this part A. Now for part B, he is asking to find the minimum value of angle alpha at which the bars start sliding down. So you can say that the angle of inclination is raised slowly, and we have to find that angle alpha at which both these blocks are at the verge of sliding. Means up to that point we can take the acceleration of the block equal to 0. So for this we have to add these equations 3 and 4. So adding equation 3 and 4, we will get W, the acceleration, equal to sine of alpha minus m1 k1 plus m2 k2 divided by m1 plus m2 into cos of alpha and into g. So in order to calculate part B, we have to put this value W equal to 0, and that will yield us tangent of alpha, and that tangent of alpha is equal to m1 k1 plus m2 k2 divided by m1 plus m2. So that angle alpha is the minimum angle at which the blocks are at the verge of sliding, and if we increase alpha a little bit more, then these blocks will come into acceleration and they will move with a common acceleration W. Clear?